So does clay have a large particle size or a small particle size? Excellent. Clay is the smallest. So since clay is the smallest, can it trap a lot of water, or can it not trap water very well at all? So think about big rocks and small rocks. So you said clay is super small. So think about the opposite, big rocks. Can big rocks trap a lot of water between those rocks? Or do you think super, super tiny that you can't even see them rocks would be able to trap water better? Yeah, clay can trap a ton of water. All right, and that's why clay is used to make things, to shape things, is because it is able to trap water and nutrients, excellent, in between the actual particles. And so that's why it can be shaped. But the other thing is that, clay can be really, really difficult to work, right? It's hard. And so that hardness, that difficulty to actually penetrate, to get through, is why it is typically not great for planting things. All right, the more clay that you have in the soil, the more difficult it is for roots to penetrate through that. Sand is super easy for roots to penetrate. But at the same time, sand does a really poor job at retaining water. All right, so this texture down here represents sand, and we see, no surprise here, the percent of sand has to be between 90 and 100% to be classified as sand. Okay, and then pure clay, basically we're talking about 50% or more of the soil. If it's clay, then that soil texture is classified as clay. And then we have, here's the Goldilocks zone of loam. Right? Loam is pretty much the ideal soil for most plants. They want loam. And so about what percent of loam, of the loam texture, is made up of clay? So you have to use the left-hand side of the triangle. About what percentage of loam is clay? Oh, didn't mean to make a circle. So we're looking at clay over here, and I'm asking about loam, about what percentage of clay is necessary in order to create that loam texture. So remember, when we're looking at this texture triangle, the direction of the numbers here tells you which line you need to be following. So 90% goes across, 80% goes across, 70 goes across, 60 goes across. So if we had 60% clay, that would land us in the clay texture territory. Great. So 20% clay will get us to loam. All right. What percentage silt gets us to loam? In this spot in particular, but you can give me a range too. So remember, look at the direction of the numbers to tell you which line to use. So we're looking over here on the right-hand side at silt. We see that these numbers are pointed down. So here's 10%, here's 20, here's 30, here's 40, 50, 60, 70, 80. So saying 80 would get us to something very silty. So 50, sure. down to 40, 30, right? Somewhere between 30 and 50% silt will get us that loamy texture. Remember, silt is, you're not gonna be able to build anything out of it. It's not gonna trap water in between the particles, but it will, as silt builds up, silt can hold water as a layer really well. It slows water down. And so that water will not penetrate the soil as quickly. And those clay particles can hold on to it. But silt is easier for the roots to penetrate. And then the final component is sand. So about what percent of sand makes up loam? So looking at the bottom here. Yeah, right around 40%. So if you've got about 40% silt, 40% sand, and about 20% clay, then that's pretty ideal soil for most plants. Right? There are some plants that have different requirements. There are some plants that require higher sand percentages, sandy loam, like carrots really like sandy loam. There are other plants, like corn, that don't care about their roots penetrating because their roots are all focused on the surface of the soil. And so they don't mind more of a clay loam or even a clay. But in general, if you want to grow lots of plants, you want to have loamy topsoil. All right. Any questions about this? And so I mentioned a lot of things that could be a difference between sand, clay, and loam, but you know, you could have said something else. That's perfectly valid. All right. Come on, there we go. As usual, we will be having yoga again this week, Wednesday from 9 a.m. to 10 a.m. So go ahead, make sure you join us. It's a great way to start your Wednesday. And seeing as we don't have ESS on Wednesdays, it's another good way to make sure that you're keeping up with your daily routine. So here's what we're going to do. We're going to briefly review 5.1. We are not going to do a full review of 5.1 because the question set just posted. So I'm not going to be reviewing the question set, but we will talk about a few of the things that we talked about in the lecture, just to make sure we're all on the same page with 5.1. And then we're going to start 5.2. And if you want to go ahead and get ahead of the game, get on Nearpod. The code is VBCRT for 5.2. And like I said, we will be doing kind of, I'll be the reporter on the ground. Mr. Tout will be taking the lead on 5.2 tomorrow, so that I can show off the kinds of things in my garden that you are actually going to see on this lecture. And then this week's work, by Sunday, you need to have question set 5.1 done and the lecture notes for 5.2. All right, and you'll see the same thing over here on the schedule that I posted a few weeks ago.
We don't do reading notes anymore?
You may absolutely submit reading notes. It is obviously, it is a really good idea to do the reading ahead of time, ahead of the lecture. And you will get credit for the reading notes if you submit them. But you, like anything else at this point, you're not going to get docked points by not doing something. Your grade can only go up.
Consider an opportunity to boost your notes grade, right? So all of these are sort of opportunities you guys are taking advantage of to get your grade up from the third quarter.
All right.
That sounds very gooch.
Yes, George, that actually was exactly the words running through my head. Okay, so 5.1. If there are no more questions, let's take a look. So 5.1, I feel like it's pretty straightforward. Now, Mr. Town and I said quite a bit about it, right? And so there was the first piece about soil profiles. Can folks help us out with what the horizons are? Like maybe from top to bottom?
Oh, my back.
Oh, you're back?
Well, I was trying to give a hint.
Oh, you're back. Don't focus on the back, people. Don't make the same mistake I did.
It was maybe a bad hint.
What do we find on top of soil? Hey, organic matter, the O horizon, excellent. Yeah, so the O horizon has organic matter, and that's why it's O. After that, it's as easy as 1, 2, 3.
Now it's stuck in my head.
Dun, 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 dun. All right, so horizon A is the topsoil. Oh, horizon.
Oh, man.
Oh, that's great, George. All right. Okay, so A is topsoil. Beautiful. I'll just go ahead and give you that second one. But the question is, what is in the B horizon? Subsoil, excellent. So what are the kinds of things? So, all right, well, we'll get back to that. The next horizon that we talked about was C. So what's the C horizon? Think mom and dad. C horizon. Mom and dad was a huge hint. Hey, excellent. Parent material. And then R, think Flintstones. There we go. So one way to think about soil horizons is from bottom to top. Think about evolution of rock. Think about it eroding. Bedrock, it's just rock. It's just large chunks, slates of rock. You can think of it as just like pavement at that point. That's practically what it is. And then it gets broken up a little bit. It gets broken up by geologic processes. It gets broken up by water penetrating spaces in that rock, and it gets broken into that parent material. So larger rocks. And then that gets broken down even further, and that's where some biological processes can even happen in the subsoil. But mostly it's water and pressure and time. And so those nutrients that start in that bedrock, they get smaller and more accessible. That subsoil can then be broken down mostly by biologic processes, meaning decomposers, fungi, all sorts of little guys that are in the soil. Animals can start to break up that subsoil into usable topsoil. And typically we think of that topsoil as the top 6 to 10 inches of the soil. And then the organic matter is the grass, the plants, all that stuff that you actually see. Okay, so you can think of this as from bottom to top, the biggest down to the smallest particles. All right, the least usable to the most usable. And all of these different horizons, all of these different layers they store organic matter, organisms, nutrients, minerals, air, and water. All right, we know that most of the organic matter is in the top 2. We know that water can be stored at all levels, all right, much less in the bedrock, but water can be stored throughout. We know that air can be trapped and stored throughout. And you know, that bedrock is a great source of minerals, but it's not available to anything organic, to anything living, until it gets up to that topsoil or subsoil. We know that there are transfers of material, all sorts of mixing and leaching. What direction does water flow in through this column? Does it flow down from the organic matter to the bedrock, or does it flow up from the bedrock to the organic matter? What way does water flow? Does water go uphill? All right, good. So water goes, it rains, right? Water goes through organic matter, through the topsoil, through the subsoil, through the parent material, into the bedrock, very slowly, all right? But that allows this transfer to happen. Water pulls minerals through the soil. And here's the thing, George, is that water does actually go up in lots of cases, right? In evaporation, water goes up as water vapor. Plants that have their roots penetrating through the topsoil and into the subsoil pull water from these regions in through their roots and up through to the leaves. Okay, so water actually does travel up. It's just that water itself, as a general rule, is always going to flow down. And so because of that flow in the downwards direction, it's able to pull those minerals through that topsoil to the subsoil. All right. It's able to pull all sorts of nutrients that are in that organic matter back into the soil. That's probably the most important thing that happens as far as when water moves, what it brings along with it. But there are also organisms and the root structure of plants that help to mix the soil, that help to mix the subsoil. So that's this biological mixing part. All right. Inputs, there are inputs of organic matter. So leaf litter, dead leaves on the surface, break down and they end up decomposing. And those nutrients are then available in the topsoil. So that's a top-down input. There's also a bottom-up input, as I mentioned, of the bedrock and the parent material, breaking down, eroding in order to have nutrients in the subsoil and the topsoil. And then the major output includes the uptake by plants and soil erosion. So plants take up those minerals and water through the roots. In addition to the transformations that we've just been talking about, decomposition, weathering, there's also the broader point of nutrient cycling, which means that those nutrients are brought up through the roots into the organic matter. And sometimes, in addition to things dying, in addition to decomposers, there's also all sorts of other organisms like mycorrhizae that actually hang on to the plant roots, and they help to convert all sorts of organic matter. They help to create this nutrient cycle so that plants can take up nutrients that they need from the soil that they don't necessarily have in the soil. The soil is rich with all sorts of microorganisms, bacteria and fungi and small animals and protozoans and all sorts of organisms that are helping everything happen. There's an entire ecosystem in the soil. In fact, we could spend easily 2 months, 3 months on soil, an entire course on soil, just talking about all the processes that are happening. It's incredibly complex. Really, the all-star of the soil is the topsoil. So most of these transformations, most of these storages, most of these transfers are happening in the topsoil. And when that topsoil disappears, that means that it's bad news for farmers. That means it's bad news for an ecosystem. That topsoil is critical. This is what started the Dust Bowl. If you've talked about the Grapes of Wrath, or if you've, in US history, you talked about the Dust Bowl, that topsoil disappeared because of poor farming, because of poor economic conditions, and it prevented people from farming, prevented people from growing food. All right, and it was a major contribution to the Great Depression. We talked about the structural properties of sand, clay, and loam. So I mentioned that off the bat here. And then we mentioned the soil texture triangle. Okay, so that's as much review as I wanted to do. Any questions about 5.1, about the lecture for 5.1? Okay. So let's head out to the Nearpod. The Nearpod is VBCRT. This is lecture 5.2. And just if you're following